going to do 3.3-3.4 tonight. So we're going to start here with this polynomial. The degree of this polynomial is 9 because in standard form, the degree is the biggest exponent. And had we written this in standard form, then this would be my number in front, the -3. So -3 is my leading coefficient. The leading coefficient is always the coefficient of the term that has that biggest degree. Now, there are 4 different types of end behavior, and end behavior depends on 2 things. It depends on whether your degree is odd or even, and whether your leading coefficient is negative or positive. So if we had an odd degree and a positive leading coefficient, then my end behavior would look like this. If we had an odd degree with a negative leading coefficient, then my end behavior would look like this. If we had an even degree with a positive leading coefficient, then your end behavior would look like this. And an even degree with a negative leading coefficient would look like this. So here we have odd negative, so that's this case right here. So what that means is that as r goes to the left, f of r goes down. So as r goes to the right, as r goes to the right, f of r goes down. And as r goes to the left, f of r goes up. On the left, it goes up. On the right, it goes down. For any polynomial, the maximum number of zeros is always the same as the degree. And the maximum number of turning points is always 1 less than the degree. And that's true of all polynomials. Maximum number of zeros is the same as the degree. Maximum number of turning points is 1 less than the degree. Okay? So, having said those 2 things, if we look at this polynomial, we see that it has 1, 2, 3, 4 zeros, which means that its minimum degree is going to be 4. Okay? All right, so root multiplicity. Multiplicity tells me 2 things. First, it tells me about the exponent on a factor thing first. If I have a root or a 0, you'll see both terms used interchangeably, at u equals 5. Well, that means that the factor that gave me u equals 5 must have been u minus 5. Now, this right here is the same as saying that you have a 0. So this is also a 0. And we know that because y is 0. So if y is 0, that means this is a root or a 0. So that means that u equals -3, which means that u plus 3 must have been a factor. Okay, so these are my 2 factors. Now, saying that this had a multiplicity of 2 means that this factor had a degree of 2. So multiplicity is the degree on the factor associated with that root. Okay? And so what about this last point? Well, I use Any other point, any point that is not a 0, that does not have a y value of 0, I'm going to use to help me find my leading coefficient. So here, what I have so far is that k of u equals some leading coefficient, I don't know what it is, so I'm just going to call it a, times these factors. And I know that I have a point at 0, negative 48. So what I'm going to do is I'm going to plug in 0 for my u and negative 48 over here for my k of u, and then I'll solve for a. Okay, well, 0 minus 5 is negative 5, squared is 25. 0 plus 3 is 3, and then we're going to multiply it times that 25. So this would be 75a. You don't have to do any of that in your head. If you grab your calculator and you type this in, you'll get 75. Okay? And so then we'll divide both sides by 75, and we'll get that a equals negative 48 divided by 75, and then we'll go math, enter, enter, negative 16 over 25. So that is my leading coefficient. So then my final answer would be this, except instead of a, I'm going to write my leading coefficient. Okay. We're going to do the next problem almost the exact same way as we did that one. The only thing is that they didn't tell me multiplicity here, but multiplicity also describes the behavior at a 0. So here, I know I have a 0 at x equals negative 2. XR, whatever, more in your dumb letters. I know I have a 0 at r equals negative 2. At that 0, my graph is, this is crossing straight. And when the graph crosses straight, that means that we have multiplicity 1. So r equals negative 2 would mean a factor at r plus 2. And the degree of that factor is going to be 1. And then to the first, but when it's to the first, we don't write it. Okay, next, I have a 0 at r equals 1. At r equals 1, we see a bounce. So see how it bounces off of r equals 1 and comes back up? A bounce means we have multiplicity 2 because it says smallest possible. Really, that could be any even. So it could be multiplicity 4, it could be multiplicity 6, it could be multiplicity 100. But they asked us for smallest possible, so we'll go with 2. So r equals 1 would mean a factor at r minus 1. And the multiplicity of that factor is 2 because it's bouncing. All right, one more. I have a 0 at r equals 4. Now this we say cross curved. This is crossing curved because it doesn't go straight through, it curves through. And when you cross curved, that means that you have multiplicity of 3. And we say 3 because we want the smallest possible. Really, it could be any odd that is greater than 1. But again, 3 is the smallest odd greater than 1, so that's what I'm going to go with here since they're asking me for smallest. Factor, and that is to the third power. Okay, I need any other point in order to be able to find my leading coefficient. So far I have g of r equals a times this, where I do not know what a is yet. That's my leading coefficient. I see I have a point here at 0, 2. So that means that when r is 0, g of r is 2. So let's plug that in. Now, keep in mind, you can plug in any good point. So like, see how it goes through right here? You can use that. See how it goes through? Well, I can't tell if it goes exactly through here. But if you see any good lattice point, you can use it as long as it's not an intercept. Okay, as long as it's not one of these 3 roots. I should say as long as it's not an x-intercept. Okay, so 2 equals a times 0 plus 2, 0 minus 1 squared, 0 minus 4 to the third. And again, I'm going to do this in my head, but you don't have to. If you want to use the calculator, go for it. So that's just 2. Negative 1 squared is 1. So far I have 2 times 1, which is just 2. Negative 4 to the third is a negative 64. Negative 64 times 2 is negative 128. Or put this in your calculator exactly like you see it, press enter, you'll get negative 128. Divide both sides by negative 128. And then a will be negative 1 over 64. When we reduce 2 over 128, we'll get 1 over 64. And so then my final answer here would be g of r equals negative 1 over 64, r plus 2, r minus 1 squared, r minus 4 to the third. So let's look at the next one. All right. In factored form, the degree is the sum of the multiplicities. That's because the rule is that when you multiply, you add exponents. So here, if we were to multiply all of these back together, we would have to add these exponents. So this would be 1 plus 4 plus 3. So the degree of this is 8. And now your leading coefficient is the number that would be in front if you were in standard form. So I don't need to worry about these constants. So what I have, and I don't need to worry about the variable either. I need to worry about the coefficients. So what I have then is the number in front times this 4 times this 2 to the 4th times this 2 to the 3rd. So again, you just take the coefficients and their exponents, multiply them all out. That will give you your leading coefficient. Negative 0.031 times 4 times 2 to the 4th times 2 to the 3rd. So negative 15.872. Okay. So we have even degree with a negative leading coefficient. That means that my end behavior looks like this. So on the right, as t goes to the right, h of t goes down. And on the left, as t goes to the left, h of t also goes down. To find my t-intercepts, I set each factor equal to 0 and solve. So this would be -7 plus 4t equals 0. When I add the 7, I'll have 4t equals 7. Divide by the 4, and I'll have 1.75. Okay. -9 minus 2t equals 0. So add the 9 and I'll have -2t equals 9. Divide by the -2 and I'll have t equals -4.5. Two t minus 9 equals 0. Add the 9. Divide by the 2. So those are my t-intercepts. And then we're gonna, to get my y-intercept, we change all of our t's to 0. So that would mean that we would have -0.031 times -7, but this 4t would be 0, so really just -7, times -9, but this 2t would be 0, so really just -9 to the 4th. And then this 2t would also be 0, so another -9, this time to the 3rd. So that's -0.031, -7, -9 to the 4th, -9 to the 3rd. So 1,037,904.273. Okay. All right. So we just said that to find the degree, you add the multiplicities. So a multiplicity of 76 plus 1 plus 97 is 174. And now there are no coefficients here. So the -11.7 in front would get multiplied by 1 to the 76 times 1 times 1 to the 97. So it would just be this -11.7. So even degree, negative leading coefficient, that would be down and down again. So as t goes to the right, h of t goes down. As t goes to the left, h of t also goes down. Okay, I'm going to pull this back right here because this is what it's asking for. It's asking for what's happening. So here, if this t plus 8 factor has a degree of 76, that is even multiplicity. And since the multiplicity is even, the graph will bounce. This t plus 6 that gave me the t equals -6 has a multiplicity of 1. So the graph will cross straight. And this factor that gave me the t equals 9 has a multiplicity of 97. So the graph will cross curved because the multiplicity is odd and greater than 1. And you'll see when you pull these boxes down that those will be your options. Okay. One more. The degree in standard form, again, is the biggest exponent, so that would be this 3. That means that the leading coefficient in standard form would just be that 9. So odd degree and a positive leading coefficient means my end behavior looks like that. So that means as r goes to the right, h of r goes up. And as r goes to the left, h of r goes down. Now, to find the r-intercepts here, I'm going to put this in standard form. Ooh, that should be a minus. And then I'm going to factor. First step to factoring is always looking for a GCF, so we absolutely have a GCF of 3 here. $54 divided by 3. I know it goes in. I know this. Don't tell me. Don't tell me. Don't tell me. 18. So in a situation where you are solving, now let's just leave it there. Leave it there for now. Now we're going to factor this. So what do a 3r squared and a 3r to the third and a 2r squared have in common? They have an r squared, and that would leave me 3r minus 2. What do a minus 27 and an 18 have in common? They have a 9. Since the 27 is negative, I take out the negative. And then don't forget to put your 3 back in front. And now these two things have a 3r minus 2 in common, and then my other factor would be r squared minus 9. So then you set each one of these equal to 0. So this would be 3 equals 0, 3r minus 2 equals 0, r squared minus 9 equals 0. I mean, or you could keep factoring, right? R squared minus 9 is r minus 3r plus 3. You get the same answer either way. So 3 doesn't equal 0. Forget that. 3r equals 2. When you add the 2, r equals 2/3. They're asking for decimals, so that would be 0.667. And then here, r squared equals 9. So r equals plus or minus 3. And again, we probably should have kept factoring this and making it r minus 3, r plus 3, TBH, because if they'd have asked for factored form, this would have been factored form right here. Okay, so we had r plus or minus 3. So then we had positive 3 and negative 3 as my zeros. And so then the last piece that we were missing, which thank you for hanging around for 8 minutes of ridiculousness. If we have 0, if we're looking for our y-intercept, we make our x 0, or in this case r. So if I made r 0, this would be 0. So that would go away. This would be 0, so that would go away. This would be 0, so that would go away. And all that would be left would be the 54. So my y-intercept would be 0, 54. And so in general, in standard form, that y value is, that y-intercept is your constant term.